Thanks a lot for the opportunity to present our work today. My name is Kristina Knauf, Associate at MVRDV in Rotterdam. I will open today the session on coastal adaptation as a next frontier. MVRDV is a globally operating design firm with offices in Rotterdam, Paris, Shanghai, and Berlin. We work on a broad range of scales of spatial issues and research, always with global urgencies in mind. And we do this with an in-house group of experts of sustainability and resilience, which I am part of. And we, together with our design teams and our principles for building resilience, develop concrete solutions that answer to the UN Sustainable Development Goals. And with our methodology, we try to turn isolated thinking into integral designs that answer, for example, water issues by looking as well as at urban issues that our cities are facing, such as pollution, land use, or mobility. So how can our design approach actually contribute to adapting Asian cities to water challenges ahead? When looking at coastal conditions, we see a paradox. We see that there are inundation hotspots, especially in Southeast Asia, that are very much paired with some of the fastest growing cities. And there is a correlation, of course. But the question is it a vicious cycle that we need to break, or can we actually use this chance of growing pressure on our urban systems to leverage this growth to adapt our cities in different ways to these changing water conditions? So in our practice, we investigate how we can use community needs and urban pressure as driver to change the way we live with water. So while my colleagues of Blue 21 and BAM will guide you through some examples on floating developments and coastal defense infrastructure, I will show you today some examples of how MVRDV adapts existing cities to face water challenges ahead. So how do we contribute to that? First and foremost, we leverage community needs and desires to build more resilient cities. In our contribution to the Resilient by Design Challenge in the San Francisco Bay Area, we look at the whole region and the watershed system to understand the situation. And we do this first and foremost with the people that live in the place and know the situation the best. But as well, we analyze the water system in correlation to urban issues such as mobility, social segregation, fragmented policy making in order to understand the actual dynamics in the region. And from here, in our research, we understood that the existing system is very fragile and actually needs more robust links and additional links in the system in order to face the shocks and stresses ahead. So what we did in our design is that we developed a prototype that we call Connect and Collect. That is a public space system that integrates water cleaning and water storage solutions with new last mile mobility solutions, as well as community amenities that are lacking in the current situation. And as such, we create orientation hotspots within the community that can become valuable hubs for the community to build resilience on a social level in daily life situations, but also hubs for water storage and cleaning, and as well emergency management during disaster situations. And this prototype we then customize with local communities. In our case, we went into the community of South San Francisco and really talked with them in very analog ways, trying to distill current conditions, but also their ideas and wishes for the future ahead, and also try to develop together with them new design solutions using digital tools to not just visualize them, but also communicating them and getting feedback from the communities on whether or not these solutions could be feasible and desirable for them. So with this, we develop very customized local solutions that over time, when communities contribute, build regional resilience. Next to that, we design dense new neighborhoods that actually have a new way of living with water. In our project Bastide Niel in Bordeaux, we transform a brownfield site into a livable neighborhood within a floodplain of a river. And we do this by lifting the buildings and actually installing, like you can see on the right here, a built water storage system underneath the buildings that allows the neighborhood to exist without any harm within fluctuating situation of the river. And next to that, we design buildings in such a way that they also orchestrate urban shadow in order to prepare this neighborhood also for urban heat in the future to come. So in that sense, we create livable neighborhoods in symbiosis with river landscape. And lastly, we also create strategies that leverage integral development to cross-finance water upgrades. In our project, Barapula Springs in New Delhi, we actually clean a river by urban development. And we do this by strategically identifying hotspots along the tributaries of the very polluted river. And in these hotspots, we develop an urban development strategy that actually creates financing mechanisms through development that actually finance cleaning facilities of the water system, as well as public space upgrades. And as such, they turn the current very polluted, segregated situation into livable spaces, new neighborhoods that actually also connect existing neighborhoods that were previously disconnected. So with these examples, we would like to summarize the takeaways for Asian cities that we have. We believe that you need to create new perspectives for urban communities to live with water. And you need to do this by using integral design thinking that actually links water issues to other issues that are playing in the cities right now and that the cities will face in the future in much more harsher ways. And as such, together, we can build wonderful, resilient, and livable cities.
My name is Blanken. I'm the Managing Director of BAM Infra Consult, Delta Marine Consultants, and BAM Infra Asset Management, part of the Royal BAM Group. Royal BAM Group is an award-winning engineering construction firm active in the construction, property business, civil engineering business, as well as in public-private partnerships. As Royal BAM, we provide sustainable solutions across the construction life cycle, and we are recognized as a leading sustainable construction firm. Delta Marine Consultant is an engineering consultancy firm and integral part of the Royal BAM Group. We tackle challenging engineering assignments on a daily basis, from concept phase to detailed design. While addressing the client's needs, we strive to minimize the impact on the environment in all phases, ensuring the protection against waves, storms, flooding, adapting for climate change, and, of course, rising sea levels. We deliver constructible, competitive solutions that actually work and are sustainable. Being part of Royal BAM Group, based in the Netherlands, a company with a long history in water management and water protection, in combination with our local presence in Singapore for more than 3 decades, we understand the challenges Singapore and other countries in Southeast Asia are facing, like more frequent and heavier storms and rising sea levels. What is clear is that we have to adapt to the climate changes in order to ensure the safety of our people and to protect our cities and economies. Together with MVRDV Blue 21, we provide a compelling story about coastal adaptation. It's inspiring to hear all the stories and ideas in this session on how to accommodate climate change. We, as engineers, are specialized in coastal adaptation and are here to translate the concept into practical and applicable solutions. Let me take you along on our journey developing breakwater protection measures. In the early 2000s, we noticed that the concrete armor blocks available at that time weren't adequate for future coastal climate changes. We decided to develop a product that would use less material, fewer elements compared to other single-layer armor solutions, and which could be placed more effectively thanks to its unique shape. This process resulted in X-Block, a single-layer concrete armor unit. Since 2003, more than 600,000 X-Blocks have been placed in more than 30 countries to protect coastal communities against heavy water conditions. X-Block has proven to be a success. Following up on that, we looked into other coastal conditions that could use single-layer concrete arm protection. The development was accelerated by the tender to reinforce the Afsluitdijk and put in the market by the Dutch government in 2018. The client asked for a solution combining resilience and aesthetics. With these in mind, we developed X-Block Plus, pattern-placed single-layer concrete armor, a more economical and sustainable wave production. X-Block Plus uses up to 50% less blocks compared to other technologies. The unique form of the X-Blocks Plus allows for quicker and more reliable and industrial construction methods. Furthermore, the elements are easily replaceable, can be reused for future projects, and visually fits into the surrounding landscape. As you may know, we won that bid. The Afsluitdijk renovation is going to be finished in 2022, which is next year. A layer of 75,000 X-Block units protect the country of the Netherlands against sea level rise. In the process, we fully digitalized the design of the elements and the molds. After the success of the Afsluitdijk, we applied X-Block Plus in coastal resilient projects in Poland and La Réunion. The interest and demand for X-Block Plus is growing rapidly. Many other clients see it as a solution to shield their communities and properties from unpredictable weather conditions. The journey is far from over. We keep innovating with the X-Block family towards more sustainable, economical, and climate resilient projects. We have our own water laboratory to test new ideas in specific circumstances and wave conditions. A particular field of interest for us is shore protection in moderate wave climates where conventional rock armor is still commonly applied at a high environmental cost. Rock extraction and transport from the quarries over long distances bring about a huge carbon footprint. We see locally produced concrete as a more sustainable and economical alternative. We are currently developing the EcoBlock in joint venture with E-Concrete. There we use low carbon concrete with less cement content with an additional positive effect on the marine life on and around the armor. Another innovation we are working on is the Extreme, smaller blocks protecting rivers from score and erosion. If you want to know more about our products and the development of adaptable, climate-resilient shore protections, please visit our website, dmz.nl and xblock.com. We would love to see you tomorrow in the technical session, Climate Resilience and Adaptation, Shore Protection, hosted by Pieter Bakker and Bas Rijdijk. Thank you very much and have fun.
Good afternoon, ladies and gentlemen. My name is Rutger de Graaf of Blue 21, and I will be talking about realizing climate-resilient floating projects with a positive impact on the planet. A little bit about Blue 21. We're a global knowledge leader in the technology, design, and realization of floating projects. And we aim to have a positive social and ecological impact. We're maritime urbanists. We have a unique collaboration between maritime engineers, architects, urban planners, and civil engineers. We're pragmatic visionaries. We have a big vision for the future, but we also work on concrete projects today. And we work together with our team. We have partnerships with world-leading research institutes, companies, and investors to be able to have a bigger impact and to realize floating projects in practice. So why do we think floating projects are the future? I have identified a couple of global challenges for 2050. The urban challenge. More cities will be built in the next 40 years than in the past 4,000 years. The climate challenge, projected sea level rise, but also more extreme natural hazards and climate events. And the food challenge, we have a huge land scarcity to feed 10 billion. And in our company, we have done research that shows that our global land scarcity will be 22 million square kilometers by 2050. And that's about the same size as the total land area of North America. So how is this challenge generally tackled in common practice? So what we see is coastal cities growing and sacrificing farmland, sacrificing nature, moving into floodplains. Obviously, these are not optimal way forwards, in our opinion. Moving higher up, urban densification can solve part of the problem, but we think the water, 70% of our planet, can create what we need to deal with these challenges. Water provides a space for growing cities, but also for floating biofuel, floating cities, aquaculture systems, and hydroponics. So it's not only about living on the water, also food and energy provision on the water. We see floating cities not as autarkic, self-supporting, isolated things, but really as a symbiosis between cities of land and water. We see the floating cities utilizing waste nutrients, CO2 and heat from the cities on the land, and use it in a productive way to create algae systems, food systems, and aquaculture. And by doing that, we create a symbiosis between those two systems. We also see floating cities as part of the 5 capacities of resilience. As very recently, we have proposed this together with Henk Ovink. Threshold capacity is building dikes against flooding. Coping capacity is how do we deal with flood? How would you reduce damage? Recovery capacity, how can we recover after a flood? Adaptive capacity, how can we adapt to the uncertain effects that we're facing, such as climate change? And transformative capacity, how can we address the root causes of climate change, but also transform our society? And we think floating urban development can be a very interesting part of these 5 capacities of resilience. There's a growing momentum of floating solutions. Living underwater has become part of the blue route in the Dutch National Science Agenda. Also, UN Habitat has convened a high-level roundtable to talk about the solution for climate adaptation. In 2020, we saw the 2nd World Conference on Floating Solutions in Rotterdam. And we launched the largest open source knowledge base on floating urban development. Space at Sea, a Horizon 2020 research program commissioned by the European Commission on large-scale multi-use floating platforms, was finished last year. And even this year, also some really interesting milestones. Floating urban development was mentioned in the joint statement of the 1000 Cities Adapt Now program. And also the Global Center on Adaptation is moving to a floating office. Floating cities is not something of the future. The building blocks are there in place. It's proven technology. These are all projects that they're out there. They're realized. It's not a futuristic thing, but the skill is lacking. So we aim to increase the skill of floating solutions. How do we do this? With research and development. We're studying the ecological impact of floating urban development with underwater drones and sensors. We're studying modular utilities, platforms and systems, such as also in the picture in the middle, you see we have realized a floating solar system. And also we're studying large-scale platforms with wave-basing tests, for instance, with Marian, to study what are the wave impacts on large platforms in maritime conditions. It's not only about research, it's about realizing real projects to show that it's possible. This is the Floating Pavilion Rotterdam, the place where I am right now. And we realized this project already 10 years ago. And you see here a stable platform of polystyrene and concrete, which enable you to create large dome structures with light inflatable cushions. And this is what the end result looks like. The Floating Pavilion Rotterdam is now also the office of Blue 21, has become a symbol, international symbol of climate adaptation, as it adapts to the sea level change on a daily basis. But our ambition goes much further than this. This is a project we're involved in Finland, Estonia, a big tunnel project of 100 kilometers where Tallinn and Helsinki will get connected. And you see that 4 floating islands are planned as part of this project. And we're working on this project together with the Shimizu Corporation, a really large company from Japan, a contractor, but also with the Angry Birds investor, Peter Vestabaka, who is the initiator of this tunnel project. And we work together with him to also create the floating islands. At the moment, 2020, 2030, we're in coastal areas. That's our vision at the moment, creating floating urban development near shore in old port areas. But as technology further develops in the near future, 2040, 2050, it will become possible to create floating cities in the middle of the sea. These floating cities would be surrounded by floating algae systems to suck out the CO2 from the atmosphere so that we can both adapt to climate change, but also address the root causes of it. This is what I wanted to share with you today. I encourage you to find out more about this topic on our website, blue21.nl, or if you have any questions, feel free to send me an email. I would be happy to answer them. Thank you very much.